What's going on, everyone? My name is Johnny Bandon, and I'm your CCNA instructor for this CCNA video series. And in this video, we're going to go over first hop redundancy protocols, or FHRP. So before we get started, if we go ahead and go into the CCNA exam objectives, we can see for under section 3, the only thing the CCNA is going to test us on is the purpose, functions, and concepts for first hop redundancy protocols. So really, we could have broke this down into like 2 slides. Purpose, have redundancy on our network. Functions, one's the primary router, one's the backup. Concepts, you have hello packets that create neighbors, and you have, again, active and standby, chosen by priorities. And really, we could just break it down so simple like that. However, I would just feel disingenuous if we didn't go into just a little bit more in depth on FHRP, especially HSRP, which is one of the 3 protocols we're going to go over, because that's going to be one of the more common ones and the Cisco proprietary one. So that being said, let's go ahead and jump into it. Here's our agenda. So we're just going to have a very basic overview of first hop redundancy protocols. Then we're going to go into why we need them, what the purpose is, right? Hitting that exam objective. We're going to go over the 3 different protocols, the little differences between them, right? All 3 accomplish the same goal. One does load balancing, one's not proprietary, 2 are Cisco proprietary. So going over that. And then we'll go over HSRP, and we'll go over to a lot more different features and functions. And I'm trying to have better handwriting, and functions of HSRP. And then we're going to go quick overview of VRRP. And then we're going to do a simple demonstration of how to configure HSRP. And this will be accompanied by a lab on EVNG. Okay, so FHRP overview. So a first hop redundancy protocol is a technology that allows more than one default gateway to be used on the LAN, meaning that we could have 2 routers or routing devices. These could be like distro switches, and both can function as a default gateway, with one being the active one actually forwarding traffic on the wire, and one put into a backup state or a secondary state, which will take over if there's any failure at the default gateway's link right here. So FHRPs, so how do we set the primary and secondary? Well, first hop redundancy protocols will actually dynamically elect a primary and secondary routing devices to be used on the network. Meaning no matter what protocol we use, HSRP, VRRP, built into the protocol are parameters that set who is going to be the primary and secondary. In terms of HSRP, we have a little bit different language. We call the primary active and the backup standby. And then in VRP, we call this the primary master, and the backup we call backup. Easy, right? How do we accomplish this, though? How do our users know that they're supposed to be sending here if they're supposed to be dynamic rerouting here, right? Where now the secondary takes over. Is it just going to automatically know to switch from maybe this .1 to this .2 address? No. What we do here is actually create a virtual IP address and a virtual MAC address that these 2 routers are going to share and know about, and that these users are going to use that virtual MAC and virtual IP to send traffic to the destination. So instead of when we do ARP here at the user, we're actually going to, in our ARP table as the user, have this virtual MAC address that HSRP or VRRP uses. And in our actual NIC adapter settings, this virtual IP that's going to be shared between the 2 is going to be our default gateway. So just a quick overview and why we need first hop redundancy protocols. So single points of failure on our networks are a failure, right? It's a no-go. There's a saying that I've used in the industry, 2 is 1, 1 is none, right? Something we said in the military a lot. So essentially, if you only have one device as your gateway out, your excuse my language, shit out of luck if that one device goes down. So in a robust network where connectivity is critical to the business and your profit, you're going to have redundancy. So with that redundancy, we need protocols that can automatically fail over, right? If one of our 2 or 3 devices that route us out to the internet goes down. So we can see here in this little diagram here that distro switch 1 is the primary. Something happens here where its interfaces go down that are connected to its LAN, and now our devices are going to send to the secondary. And this is made possible by first hop redundancy protocols that these two devices may be speaking to each other, knowing, or they send hello packs to each other saying, hey, I came down, you take over routing, right? So creating router redundancy is a way to prevent our users from being down when one of the default gateways goes offline. So again, we achieve this redundancy by always having what we call an active or a primary device forwarding traffic actually on the wire, and then one device on standby or a backup that's ready to take over if the primary fails. And you see I'm using this language primary and secondary because the protocols have their own ways to describe primary and secondary, like we talked about in the last slide. Okay, so let's go over the different types of FHRPs. First, we're going to talk about the Cisco proprietary ones. So Gateway Load Balancing Protocol, that's a Cisco proprietary FHRP. The main benefit or difference between this and the other FHRPs we'll talk about is that you can actually do some load balancing. We're not going to deep dive into the algorithms and how it load balances, how it divvies up streams between users, but main takeaway, GLBP should be can load balance, and it's Cisco proprietary. Don't know if you'll see anything about this on the CCNA exam, but wanted to throw it out there. Hot standby router protocol. This is the one we're going to configure and deep dive into. This is going to be a Cisco proprietary FHRP. And again, it just allows for transparent failover of a first hop IP device. In layman's terms, it allows 2 routers on the network to be default gateways. And again, with HSRP language, the primary is going to be known as the active, and the secondary is going to be known as the standby. All right, and then we have the non-Cisco or the vendor-neutral, non-proprietary FHRP. That's going to be VRRP. And you see this a lot out in the industry because not everyone has Cisco routers, right? So if you want to, maybe you have I know this is weird, but maybe you have a Juniper and a Cisco router operating on your LAN. Don't know why you'd want those 2 different vendor clauses. But if that's a thing that happens in your environment and you want redundancy, you implement VRRP. Does the exact same thing as HSRP, a little bit different language, different hello packets, right, with the multicast addresses, but essentially does the exact same thing. All right, now let's do our deep dive for HSRP. And I laugh when I say this because this is a deep dive just for the CCNA exam, right? So let's do a little overview. So routers that get configured with HSRP work together, and they're going to present themselves as a single virtual default gateway to end devices. Meaning when we activate HSRP on the actual interfaces, they're going to begin sending multicast addresses or hello packets to each other via a multicast address that HSRP listens to. They're going to go through different states, and the end states are active and standby. And then there's priorities that set who's going to be the active, who's going to be the standby. Administratively, you set the virtual IP that the HSRP group is going to use, but this virtual MAC address you see here is going to be automatically created once you enable HSRP. So once we enable HSRP on these physical interfaces, right, we're going to set what we call an HSRP group. So literally it'll be a command like this, standby, group number, and then IP, and then we set that virtual IP address. So let's just do this, right? And then you have to set that exact same thing on this other side, the exact same standby, group number, and virtual IP for these two routers to participate in an HSRP group that does this failover, right? So how do we choose active and standby? So we have a default priority that's set when we configure HSRP of 100, and we can change the priority numbers, and that's going to be on a per interface level. But if things are set to default, the router with the highest IP address in that HSRP group is going to be the active. So we can assume here R2 has a higher priority because in our diagram it says it's the active one, right? Now let's say there's failover. So let me clear this up a little bit. Let's say there's failover on this, or this link fails. R1 as a standby will take over. And now it's the active router. Well, let's say this link comes back up. Does that mean automatically R2 goes back to being the active? It does not, unless we configure something called preemption, which says, and will send a hello packet saying, okay, I'm back up. I'm going to take over as active again, okay? So just something you need to know about if there's a reason why maybe one router you always want to be active versus this one really is a true backup that you don't want to be using in any length of time, right? And as we can see here, our users, the default gateway is not going to be the physical IP addresses that are set on the interface. It's going to be the virtual IP that's assigned to this HSRP group. And then with that MAC address, those last two hexadecimal digits, or this group number is going to be those last two hexadecimal digits. So actually it'd be like 0 and then E, but anyways, because you convert this number into hexadecimal. So moving on. So HSRP overview continued. Kind of just what I explained, right? This standby should take over in the event of a failure. So I got ahead of my slides again, excuse me. Again, some more key takeaways. The virtual IP address is going to be configured by the network administrator and the engineer, whereas that virtual MAC address is created automatically. All right, now let's get into some more features of HSRP or differences. So there's going to be two versions, version 1 and version 2. They function the exact same way. HSRP version 2 just has a little bit more features and capabilities. So we look at some differences here. This HSRP group goes from 0 to 4095. I need to work my handwriting. Version 2, yeah, 0 to 4095. Whereas version 1, you only get up to 255. Now, why would this matter? Well, let's say we have distro switches here. And let's say we have extended range VLANs or SVIs that we configured. And these are going to be the default gateways. And obviously, we're going to build them on both sides. Well, administratively, it would be a lot easier for these SVIs if we could match this HSRP group to the actual VLAN number. And let's say we have a really crazy robust network with over 255 VLANs and we want redundancy, version 1 just ain't going to cut it, right? So version 2 gives us a lot more room to grow our HSRP groups, especially if we have that huge, robust campus network. Now, I've never personally been on a network where I need to have more than 255 HSRP groups, but with HSRP version 2, it allows it. We see the destination multicast addresses. They change with version 1 being 102, version 2 being 102, version 1 being .2 here in the last octet. And then we see the virtual MAC addresses also change. So with HSRP version 1, these last two hexadecimal digits would change based off the group number. Now, that makes sense because these last two hexadecimal digits would have been 8 bits total. And 8 bits equals what? 255. Well, now, with HSRP version 2 and the group number is going up to 4095, 2 hexadecimal digits wouldn't cut it. 3 hexadecimal digits is 12 bits, and 12 bits, right, we do our powers of 2, equals 4095. What? Crazy. So that means if we're looking at this virtual MAC address here, 0C9F, we know just from this middle segment, it's version 2, right? You can see the differences there. But if we see this, 00A, what HSRP group is this? Well, we have to look and break down the hexadecimal digit into binary for that, right? This is going to be the number 10. So if I configure it standby group 10, my virtual MAC address would be this right here. Because in these hexadecimal digits, 0 through F, right? So 1, 2, 3, 4, 5, 6, 7, 8, 9, and then A, B, C, D, E, F. A is going to equal the number 10. So pretty cool, right? So you got to kind of take note of that. Another thing of version 2 does is it supports MD5 authentication. So you actually can do some authentication with HSRP version 2. Cool. Now let's go over that HSRP priority. So HSRP priority can be used to determine who the active router is. Maybe you want to set that automatically. So by default, the priority is 100. And then if those priorities are equal, the router with the numerically highest IPv4 address on this interface that's being part of that HSRP election will become the active. And then, of course, the higher priority also wins if we set it. And the range of that priority is 0 through 255. Okay, and then here's the states that HSRP is going to go through. And in our labs, we'll do a Wireshark capture and see this. But the last 2 states that the HSRP routers are participating in, HSRP, should be standby and active. Those are the final states, right? Again, don't need to go too deep into this for CCNA. And then let's go over preemption. So with preemption enabled, we can always ensure that if this active router is online, that it will always be the active router, even in the case of failover, right? So really the preemption is the ability of a HSRP active router to trigger the re-election process, even when it goes down and comes back up. Okay, and then quickly let's go over VRRP, because what I just described, HSRP, VRRP essentially does the same thing, right? Key differences here. So it's going to elect a master and a backup, just terminology, right? VRRP also has its own virtual MAC address that's going to use. So if you see this, you know it's VRRP. And then the last 2 hexadecimal digits are also the group ID. It has its own multicast address, and it actually has 3 versions. HSRP does kind of as well for IPv6 compatibility, and VRRP does the same thing. It has version 1 and 2. Then version 3, if you configure that on a router, you can do IPv6 and IPv4 for VRRP. Okay, and then configuration. So really, configuration's easy, guys. The only command you need is this command right here, the standby 1 IP command. Notice it has to be the same on both routers because they need the same group number to be able to talk to each other and get to that active standby state. And the virtual IP addresses also need to be the same. And then we can see here we set the version 2. So by default, HSRP is going to be version 1. You have to set it to version 2. And then we see our priority command and our preempt command. So right here, we're making R1 the active router. Awesome. And then we have our verification. There's really only 2 commands you got to know about, right? That's going to be the show standby brief command which is going to show you quick information, right? What you are the active or standby, the interface IP address of the standby, and then your virtual IP. And then show standby is going to give us a lot more information, but when you have multiple HSRP groups, that can become a lot. All right. So that was our just quick down and dirty over FHRPs. I want to thank you all for viewing.